Welcome to part 6. We've been looking at parsing, something you probably didn't consider until you saw this video series. Most read functions that are used assume that you have already set up well-defined data, and that often is not the case, especially for large data sets. In some instances, data sets are created by people entering information and then the data set is automatically created, and if the people don't enter it in the way you expect them to, you could end up with messy data. So I talked last time about the steps that the read CSV function goes through, and it starts by guessing at what type of data is in the first 1,000 rows. So I'm going to show you an example of how even that can be a problem. This is an example that Hadley Wickham actually built into the tidyverse called challenge. So we could use the data right from the tidyverse, but I have downloaded the data so that we could take a look at it here. It's in an Excel spreadsheet. So we have a column X and a column Y. So it looks here like we have integers. And here it looks like we have missing data. And so if we were going to guess based upon the first 1,000 pieces of data, which takes us way down here, there we go. If we were to guess based on the first 1,000 pieces of data, we would guess integer and then just missing. Let me see if I can widen out these columns. So, okay. So now look what happens when we get to line 1002, which is our 1001st data point, because the first line is the header. This is not integer data, it's numeric, but it's double data here. And this looks to be like a date. So it is not missing data, it's a date. The missing data is only in the first 1,000 rows. The integers are only in the first 1,000 rows. Okay? So let's see what happens. I'm going to go ahead and read right from the tidyverse. So that's what this read R example is about. It's being able to take examples right from the tidyverse. And I'm going to put it in an object called challenge. So it gives us a bunch of warnings. Let's go ahead and look at that all put together for us in this tibble, which is one of the nice advantages of a tibble is the problems are stored with it. So let me make this a little bit bigger window and let's look at the problems. And what we see is that the problems begin on line 1001 because it expected to see an integer, but instead it had something else other than an integer on line 1001 for the X column. And then for the Y column, it expected character, but it looked like it's something else. And in fact, it's a date. And then it says we have 990 more rows. So the tibble has a problem starting at 1001. Now, notice how nice this would be if you had not known there were problems and you read in the data, you got these warnings, and then you just looked at the tibble, and it identifies exactly for you where to go in your data set to look for the problem, as opposed for you having to just scan and try to find it. Imagine, for instance, if it was only one row in 2,000 rows. You could scan for an hour and not detect it, but you look in your tibble and you can see which row it's in. That's pretty cool, isn't it? So let's see if the first column should have been read as a double. The column functions do the same as the parse functions, but with a column of data that hasn't been read yet. The parse are for vectors that are already in R. So here's what we're going to do. We're going to read in that challenge. We're going to look at the first column as a double. So remember that this column types is going to tell us to parse based upon what we say these cols are. So this is going to make the X column a double and the Y column a character. So let's try that. Okay, now let's look at challenge. All right, so we've now got a double here and a character here. Let's look at the tail. Well, we already looked at the heads. That's automatic in the tibble. Let's look at the tail. So these look like they're dates. And so let's do this. Let's change so we're reading the columns in, the first one as a double, the second one as a date. Again, no warning messages. And now we have met our goal. Double and a date. So we're all good. So unless you're confident about the nature of your data, using column functions is a good idea. I think I already mentioned once that what I often do is read everything in as a character. And then once I read it as a character, I convert it into the types it should be and make sure the conversion works correctly, because if it doesn't work correctly, of course, that's a sign that I'm parsing incorrectly. Once you have data looking the way you want, you can write it using the write underscore CSV from the tidyverse. So I'm going to take the challenge data right now and I'm going to write it. By the way, if you're using the library here, you could write it to the data section of your project. I could take and do this here, data. Okay, so anywhere where you have the file name is where you want to put the here. You don't want to put it out in front of this challenge thing. You only want to do it only with the file name. So this one would write it to my data folder. I'm not going to do that because I already have challenge.csv with the problems in it in the folder, and I don't want to overwrite that because I have that there for future classes. So I'm going to eliminate that, and I'm just going to write it right into my current directory. And then when I'm done showing this, I'm just going to delete it. So this is writing it to a CSV file. So let's do that. And it did it. Let's see. I think I can show it to you down here in my files. Here it is, right here. Okay. And then if I want it to read it right back in, I can read it right back in using the read CSV. Here I'm actually going to read it from Hadley Wickham's examples, but all I'm showing you is that if you know what the data types are in advance, then you can use the columns function to read into the correct data type right from the start. So that's what I'm doing here. So now if we look at challenge, notice that there's no problems listed like there were the last time. So when I only used this first line here, that's when we got the problems. But now when I'm telling it what the types are in each column, then that takes care of the problem. Other types of data can be read with other packages. If you look at the tidyverse cheat sheet for data import, I'm looking at it now. I recommend that you have this in your cheat sheet library. Some cool things that you'll find. There's a package called Haven that will import SPSS, Stata, or SAS files. That can come in very handy when you're working with a colleague who has stored the data in one of those file types. You can read directly from Excel files with the Read XL package. There's databases, XML, for those of you who know what that is. If you have an HTML file that has code in it, you can read in from that. You can save directly to an Excel file if you want. Go ahead and take a look at that cheat sheet. It has additional information about dealing with non-comma delimited files. For instance, what if you delimit with a space? Or what about if you have fixed width? That sometimes is something I encounter, is where every row in the file uses, say, the first 6 spaces for putting in the data and keeps it all at fixed width. And then the next 6 spaces for the next time. You can read that in. You can read in tab delimited. So it's worth taking a look at that cheat sheet. You'll see the power of importing in the tidyverse. Hopefully you've seen that with this subject of parsing. Now in the back of your mind, you'll always know when you're using a read function that there's parsing going on to get it from computer language in order to the language that you expect it to be. And now we have manual control over that when we have messy data. So to review, parsing is the act of separating data into parts. And the parse functions in the tidyverse parse vectors. So for example, if we want to parse it as an integer, we use parse integer. If we want to parse it as a character, we use parse character, and so forth. The guess parser function will use 1,000 rows to guess the correct parsing. And the column functions parallel the parse functions to manually parse columns. So whereas the parse underscore is for a vector, the column functions also are for a vector, but a vector that's a column in your data. And it will do the same thing as the parse functions on those columns.